All right, so it is recording. So again, this is MapTime Davis and Davis R Users Group joint workshop. We're sort of co-branding this because it is a big crossover thing. People do R, people do spatial, and they do R and spatial together. So my name is Michelle Tobias. I am the geospatial data specialist at UC Davis DataLab. And DataLab is one of the places that co-sponsors these events and helps entities like MapTime Davis and the Davis R Users Group find space and resources to do what we do. And so today with me, I'm just here as the host. We've got a bunch of folks that are making this happen today. Probably most importantly is Leah Nagel is going to be our instructor for today. She is a junior specialist at the Center for Watershed Sciences here on the UC Davis campus. I say here, I'm at home, just like all of you. But so she's going to be our instructor for today, but we also have helpers that will be helping as well. And I'll explain a bit how that will work. So we've got Joaquin, Claire, Wesley, Lauren, and Ladin will be joining us to be helpers today. And again, I'll explain in a second what that is going to look like. So a quick plug for DataLab services. You can find us online at datalab.ucdavis.edu. We help folks with the whole pipeline of data related research. We, most importantly, probably for folks on this call, we have regular office hours, drop-in hours, now virtually via Zoom. You can find out more about that on our website, but they are Mondays from 1:30 to 3 o'clock, and we focus on helping the UC Davis research community. So feel free to join us and ask questions. I particularly help folks with geospatial stuff, but we can help you with the full range of most of the things that you would generally be working on for research related to data collection and data processing and analysis and things like that. Okay, so that is the intro spiel. We're going to do a couple more things to get you accustomed to how we're going to be working with Zoom as a workshop tool. So typically when we do workshops in DataLab and also with MapTime Davis and also Davis R Users Group, we tend to follow some of the carpentries procedures. So if you've ever been to a carpentries workshop, we typically, when we have in-person workshops, we try to help everyone. We try not to leave anyone behind. It's a very collaborative kind of learning environment, but because we're on Zoom, things are going to be a little bit different. So we are going to be asking you to post your questions in the chat window, and we have helpers that will be helping you answer some of your questions. And then if there's a question that we think is important for the whole group to hear, we will make sure that Leah hears that so that we can have her explain some more about that particular topic. But your course for getting questions answered is to use the chat window to type those questions in there, and we'll try to get you what you need. But also keep in mind that a chat window in Zoom is not the same as being able to see your particular computer, so the troubleshooting is going to be a little bit limited today. One thing you can do is if something, it gets too challenging to juggle watching the Zoom and trying to follow along, feel free to watch. Like I said, we are recording this session and we're hoping to post it online so you can review it later. And the materials are also already online, and we'll get you the link to that shortly. So feel free to sit back and just watch if trying to follow along is too much. There's a lot that can be learned from just watching as well. Okay, so let's do some practice with your Zoom window. You will find if you put your cursor over at the bottom of your Zoom window, you'll see a bunch of menus pop up. Right now, what I want you to do is click on that chat window if it isn't already up, and you will see people typing in the chat window. I'm going to ask, people are starting to send me private messages via chat. Send them to everyone because I'm not going to be able to monitor those. We need everyone who is a helper to be able to see those. So what I want you to do right now in the chat window is make sure that it's sending to everyone. I want you to sign in for me. So you are going to tell us what's your name, where you're from in terms of your affiliation, and if you are staff, faculty, student, that kind of thing if you're at UC Davis. So I'll put mine in the chat window as an example. So I'm typing, I'm Michelle from UC Davis DataLab, and I'm staff. So if you're not from UC Davis, you're more than welcome to stick around. Just let us know who you are and where you're coming from so that we can have a, this is instead of doing the sign-in sheet that we normally do. This will help me know who's here and who we're reaching because that's important for us. So I'm seeing a bunch of people typing in the chat window, and that's great. Keep it up. Let us know who you are and where you're from. I'll give you another minute or two to get that typed in there. Okay, I'm starting to see it slow down. You can feel free to add your name still if you haven't done it yet, but I'm going to move on to our next thing. So one of the other tools we're going to be using to help Leah know how quickly she needs to go, or if she has a question for you guys, is the participant tool. So again, if you hover over, take your cursor and hover over the bottom of your Zoom window, you'll see one of the options down there is says participants. If you click on that, you'll get a tool that pops up, and what you'll see is there's a couple buttons down at the bottom of that tool. One is a green check mark that says yes, one is a red X that says no, and then there's some other options. So what I'm going to have you guys do is answer a question for me. So my question for you is, how many of you have experience with R already? And if your answer is yes, click the yes button. If it's no, click the red no button so you can see how this tool works. So this is a quick way for us to ask you a question. Maybe Leah might ask like, oh, has everyone downloaded something? And then you can answer her question that way. So that way we can get a really quick tally of who's in a certain spot in terms of the workshop. So great, it looks like the vast majority of you already have R experience. A couple of you are new to this, which is great. Just know we're gonna move pretty fast with the R concepts. We're assuming that you have some basic skills, but if you don't, stick around, we'll be able to point you to some resources to get learning as well if you're starting from scratch that maybe you can do later. Okay, so with that, I think we're ready to get started. I'm sorry, I got slightly distracted by some messaging that's going on, but that's okay. So I think we're ready to get going. So I'm going to hand it over to Leah, and she is going to start our workshop. You ready to go, Leah?
Yep.
All right.
Great. Yeah, thanks so much, Michelle, for setting all of us up here. Yeah, so like Michelle said, my name is Leah. I work over at the Center for Watershed Sciences at UC Davis. I'm currently mostly working on hydrology these days, but my background, my formal statistics training is in ecology. And so like a lot of ecologists, I really started learning how to do my stats in R. And I'd already had a bit of a background with GIS. And so I'd been kind of working in ARC, but the more I started working in R, the more I started learning about kind of data management practices and that kind of a thing. Kind of got more and more curious to see what kinds of things I could do with GIS and R, because it was getting really frustrating to kind of be swapping back and forth between like putting shape CSV files out of R into ARC and pulling shape files back and that kind of a thing. So this is kind of just gonna be a very broad overview of kind of what's out there in R. I'm gonna move pretty kind of fast, but again, like Michelle said, especially if you're affiliated with UC Davis, there's a lot of really great resources on campus that you can kind of follow up with afterwards. So I'm gonna start sharing my screen and hopefully don't lose all of my windows here. All right, this one. Okay, there we go. Okay, so I think first thing to do is we're gonna go ahead and go over to the GitHub website that you should have gotten. So in the email about this workshop, you should have gotten kind of that email, but the website, so it's github.com/LDNAGEL/ and then just spatial-R-4-GIS hyphen, I guess, users. So you do know kind of, if you can navigate over to that site, that's going to be really helpful because there's a lot of links on there that are kind of going to guide you over to some of the stuff we're going to be doing. Sorry, I got to go find my participants window because I want to be able to see that. Sorry, I don't know if folks have done a lot of screen sharing in Zoom these days. It moves all your windows around and it can be hard to find. All right, so because what I want to do is say, has everyone gotten over to the GitHub page? So go ahead and, yeah, so you do that yes, no thing. So let me know when you've found the GitHub page. If you're having trouble, hit no, but once you find it later, turn the no off and turn it to a yes. And I'm gonna try to find my participants window again. There it is, okay. All right. All right, so I'm gonna go ahead and start kind of talking through this. Seems like we kind of leveled off in responses a little bit. Yeah, so just gonna kind of jump right in here in the interest of time and making sure we get through as much as possible here. Yeah, so again, getting started. So if you don't already have R and RStudio downloaded, I don't really recommend trying to do that right now. Just and feel free to just kind of follow along with the video and then kind of follow up again later because we are going to record it. And also a note about the packages. So R uses packages kind of like QGIS or ArcGIS will use plugins and that sort of a thing. And it's a bit of a strange time in our verse now if you're familiar with the tidyverse or already or if you're a little bit familiar with some of these spatial packages. We've just kind of undergone we're in the process of undergoing a major overhaul of some of the spatial packages. So we're going to be a little bit careful of the versions that you're using. So go ahead and if you haven't already checked list of the package versions, you want to make sure that your packages are up to date because that's really going to affect some of the troubleshooting we can do. Yeah, and again, yeah, if you feel that you're falling behind at some point, go ahead and just keep kind of following along with the video in case that's useful to you. And then there's a lot of troubleshooting resources that we'll get into a little bit later. Yeah, so why do we want to, oh, and one more thing I want to point out. So there's going to be a live code link. So there's a link to a box link over here. And so at any point, if you kind of missed something that happened, or if things are going kind of fast, or you just don't want to be constantly typing all the time, if you click on this live code link here, it will take you to kind of just when it loads. Yeah, so text file. And so the code should be appearing here. And it's pretty simple if you just want to copy and paste as I go. That way you don't have to type everything out, especially if we start getting into longer lists and that kind of thing. Just wanted to kind of highlight that. I think it can be useful to just have that as a tab in your browser as you're following along and that kind of thing. And we'll get into kind of data downloading in a little bit here as well. So just a quick overview of kind of why use R for GIS. So first of all, it's open source. So it's always free to use. It's transferable. If you're a student, after you graduate and no longer have access to things like an Esri ArcGIS license, you can just take it with you. If you get a new computer, it's really easy to just download R all over again, download all your same packages. You can move your scripts over and then you're good to go already. Transparent analyses, you always know, when you're sharing code back and forth, you know exactly what steps other researchers took, and you also know exactly kind of, in a lot of these kind of proprietary packages, you don't necessarily know, or it's really hard to find exactly which regression analysis is going into some of like something like spatial kriging and that kind of a thing. You always know with R, there's no black boxes. It just takes some digging into the code to find that out. And it's great for scripting. If you're already familiar with R, it's a lot easier to automate repeated tasks. If you know R and not Python, you can automate some spatial tasks. And with scripting, you're increasing research reproducibility. Again, you can see that whole workflow that someone else did. And also with the automating repeated tasks, you might not make errors kind of in the process. And again, if you're already using R, you're able to just do, it's really nice to be able to do as much of your analysis in one workflow as possible. So it's pretty, so there's similar syntax to other R packages. If you're familiar with the tidyverse, one of the core spatial packages is part of the tidyverse. And so there's lots of similar syntax. There's even some shared functions. And then again, you just kind of keep everything in one workflow. So I'm not going to get into really specific detail on everything you can do with R. So the I was going to say consortium for R research. For R, it's not. So the comprehensive R archive network is CRAN. They have task pages for pretty much any topic you could think of for R related things. So there's there's a link to, I've linked to the kind of the spatial page. There's a kind of a large list of all of the things you can do, and also links to what packages you can do them with. So kind of very broad overview. So you can import and export spatial data just like you can with any other software. These packages will support kind of both open source formats like GeoJSON, but also proprietary formats like shapefiles and Esri geodatabases. And you can also handle a wide variety of projection formats. So kind of the standard underlying projection formats for both open source and proprietary data there as well. There's some really useful tools that folks have kind of developed to access some publicly available data that can be really frustrating to download. If you've had experience trying to download something like NHD plus layers from the portals on the web, that can be pretty difficult. So there's some really nice, like Tidy Census is another one, NHD plus tools. And then you can do just your simple spatial basic functions, intersect, buffers, extracts, clips, and also more advanced things. You can do point pattern analysis, like things like frag stats, landscape metrics, that kind of thing, and up to complex distribution modeling and like point interpolation. And also some basic other geometry cleaning. And you can do some mapping. There's some pretty basic mapping functions. There's more complex things. And if you're familiar with R and ggplot and that kind of thing, you know the kinds of, there's some mapping directly through ggplot, also some mapping through kind of more complicated or through related packages. That's a similar, it's a lot of uphill or upfront learning to kind of get used to the language and the syntax, but once you do it, you can customize all sorts of limited things. So most of GIS in R is kind of accomplished through two kind of primary package systems. So kind of the original kind of core package that most spatial packages in R are kind of based on is the SP package. So it's the spatial features. So they say like spatial points features, spatial lines features. So it's essentially a vector handling package is kind of the original framework. It's been around since 2004. And so most packages up until fairly recently have kind of been based on this, whether it's raster packages or more advanced functions that people have developed. So it's very central package is very useful. It can be a little bit complicated to work with, the data structure, especially if you're trying to work with the attributes. So attribute table and trying to filter by attributes and that kind of a thing, it can get kind of frustrating. But it's still a really useful package. More recently, a lot of the same folks who developed the SP package have developed the SF package, which is a new framework for handling spatial data. It's still fairly new, but it's designed to kind of adhere to these kind of more standard open source simple features standards. So kind of across the board, it's coming more in line with a lot of other open source softwares. So there's been a recent big overhaul, but that's actually more related to these updates. If you're familiar with QGIS or other open source GIS software, these updates in kind of PROJ and Geos have kind of spurred them to try to kind of update their, I'm probably going into more detail on this, but they're trying to come more into line with other open source standards. So again, the SF package is kind of this more vector database structure, but it's a lot easier to access kind of the data frame and the attribute table. And so it's a little bit more, and it's also a lot more intuitive for users familiar with R in general. So if you're used to, if you're familiar with the tidyverse, SF is part of the tidyverse. And so there's a lot of shared syntax, and you can kind of do your, like the piping and nesting functions and that kind of a thing that way. And so I just wanted to, I included this graphic because, in part because it's adorable, but also because I think it's a really great visual of how SF kind of handles data. So you have your attribute table. So it just like if you would in QGIS or ArcGIS, you have your points or your polygons, and you have your attribute table that you can call up. And in SF, everything's kind of focused around that attribute table, but the geometries, whether it's the points or the polygons or your lines, kind of come along for the ride. So they have these like sticky geometry, and I'll get into a little bit more of that later when we start really kind of using R. But so it's a fun image, but also kind of really helpful. It's very focused on the data table rather than kind of having the data table being kind of the sideline. Yeah, and if you're interested in kind of more on the history of GIS and R, I've got a link there as well. I'm not going to get into these resources right now, but just kind of wanted to highlight that this is here on the GitHub repository. This is still going to be here after this workshop is over, so you can come back and kind of find these links. And again, especially a lot of these are kind of aimed at, so apologies if you're not affiliated with UC Davis, a lot of these are kind of aimed at that, but there's resources for both if you are not. But again, just want to highlight, so DataLab offers, or office hours, and kind of other resources around there. So, all right, with that, so I think now is a good time to kind of start moving over to RStudio. Are there any questions that have come up that I should talk about here, or are we mostly kind of?
There's one I think that might be good to talk about. It's been answered in the chat, but in case someone didn't see it, someone's wondering about the downsides of R versus a graphical GIS like QGIS or ArcGIS. Like when would you prefer using a graphical GIS instead of R?
Sure. So one of the things about R is that you can do just about anything if you want to spend enough time in the code, and also like sometimes there's some packages built on packages that you kind of got to figure out and that kind of thing. So depending on how familiar you are with R, it can be more of an uphill battle in that way. I also find it personally, and everyone has a range of opinions on this, but they're definitely, I still find it easier to make kind of really kind of finalized maps in a graphical GIS such as Q or Arc, where you can really kind of, you can do a lot in R, but if you're like me and you really like to micromanage exactly where your labels are, kind of having that graphical interface is a lot better for that. And also digitization is another one. I recently did a digitization project that was pretty much entirely, the digitization part was entirely in Arc, because you can digitize polygons. So if you have aerial imagery and you're trying to delineate, okay, this is a house or this is a wetland or a lake, that kind of a thing. There are tools to do that in R, but I think that's really one of those instances where play to the strength of your program. Like Arc and QGIS are pretty built for that very visual interface there. So that's my personal preference, but I think it's kind of a combination of do what it's designed for, and also how much of a wormhole do you go down for code. And as someone who really enjoys working in R and coding, I do appreciate wormholes a lot. So there's that too. Yeah. All right. I'm gonna go ahead and yeah. So anything else coming up, or is that about? Okay. Cool. Looks like not. All right. So go ahead and let's switch over to RStudio here, and let's see if this is going to open the way I want it to. All right. Yeah. Okay, cool. So I'm not going to do that yet. All right. So I know it sounds like most folks are pretty familiar with R, but for the folks that aren't, I am going to start off a little bit slow here just to make sure that everyone kind of gets at least to a starting point. There's going to be a lot of limits to the amount of troubleshooting we can do via Zoom, but I want to try to get folks to a kind of as close to it as we can. So go ahead and open up RStudio. For folks who are new, so you have your, right now the console's kind of taking up the entire screen on the left over here. In the lower right, I'm going to kind of point over to this pane a few times, so it's useful to know. So there's a tab with files, plots, packages, help, viewer. Go ahead, if your files pane is probably automatically selected. If it's not, you can go ahead and click on there. So first thing we want to do is we're going to open up a new RStudio project. Projects are a really useful thing that kind of RStudio has built everything around. It's a really useful way to organize your different projects. So if you're working on several things at once, it's a great way to kind of keep everything related to one project in one place. So if you go over up into the upper left-hand corner, there's a kind of blue R and a blue cube with a plus sign on it. Go ahead and click on that. Don't make me do this. Okay, so you should have a new project pop up. Go ahead and hit new directory. We want to start a project in a brand new working directory. And we want to hit new project, not any of those other options. So create new project. So name your directory whatever you'd like. So we're gonna just find it. So map time workshop. All right, and then make sure it's where you want it to go. So wherever you normally keep this sort of thing. So I'm going to leave mine where it's at. So go ahead and create your project. All right, so if you successfully created your project, a couple of things should have changed. So you should be able to, up in the upper left, all the way at the top of the file pane, you should be able to see kind of your file path there. So spatial map time. So map time workshop is what I called my project. So that should be kind of the last thing there. And over in the files pane over here on the lower right, you should see kind of there's a little home icon kind of in the middle of all of that. And your file path should also be there. And you should see map time workshop, so or whatever you called your project over here. And then you should see kind of a little blue box with a rproj file extension. So there's a folder with your project in it, and then there's this kind of the RStudio file itself is that rproj over here. So we've got our project set up now. So hopefully I should have mentioned to leave your GitHub page up there. So if you go back to, so if you've already downloaded your data, don't worry about this part just yet. But if you have not downloaded the data already, so it kind of put up two different places to download the data from. So either directly from the repository, there's also a box folder. If you're more familiar with one or the other, I'm gonna go ahead and go over to the repository just so I can kind of walk through some nested folders going on. So tahoedata.zip, so that's going to be the data that we're going to be working with today. So go ahead and just click on that, left click. There's a download button over here on the right. So once you've kind of gotten to that new page, so go ahead and click download. If you haven't done that already. So save, and then save it to a place that makes sense. So I'm going to go find my So so what you want to do is go find your project directory. So here's my file. You can just save it directly into so you have that folder. You should have like a little invisible kind of rproj user. Well, actually, okay, I'm on a PC. I don't know how all this looks on Mac. But you should still have that. You still have that folder. So save it into your project folder. And then you can go ahead and pull up your Finder or your File Explorer. Oh, sorry, mine's over. Why isn't it showing up? Because it's on my other screen. All right, so open up. Yeah, and then go ahead and extract. So, and you want to see where it's extracting to. So this one's trying to make an extra folder for me that I don't need. So I'm just gonna tell it, no, don't make a new folder, just extract directly to project folder. Extract there. All right, so now we have a folder called data box, which, apologies, that was kind of an artifact left over from the way I set it up. So we want to just actually name this whole thing data. So we don't really want extra. It'll simplify our file paths later. And also if everyone's got the same folder labels, then it'll be one less thing to kind of figure out what's different between your code and my code. So what we should have in the end, so you should have your project directory and then a folder called just data. And then inside your data folder, there should be a bunch of files. If you're familiar with shapefiles, there's kind of the different components of shapefiles, and also there's a tip in here that we'll get to later. And then if we go back to our studio, so now we've got our file project or file pane over here again in the project folder should now have a data folder. And if we click on our data folder, should see all the same stuff in there. All right, so I tried to kind of walk through that to hopefully give people time to do that. Is there a way to, I don't know how to clear the votes, but I think we should try that again of, yeah, great. So if you're good to go on the data, go ahead and hit yes. If you're not, go ahead and hit no. And you can open it. All right, so I think, all right, doesn't look like anyone's kind of doing new. All right, so I'm gonna go ahead and kind of move on, try to keep going a little bit slowly with this RStudio setup to hopefully get everyone to catch up. And again, if you're having troubles either with downloading the data, if your internet's really slow, or if you kind of run into some things that the chat troubleshooting doesn't work, like feel free to just kind of follow along with the live code over here, and then you can come back to this later. We're gonna post a recording, but I'm also gonna kind of post more of a text walkthrough to the GitHub repository as well. And the GitHub repository will continue to exist after this workshop, so you should be able to find all the resources again there. All right, so last thing we want to do before we really get started is we want to open up a new script. So up in the upper left-hand corner, there's a white box with a green circle with a white check mark in it. And so you just want to go ahead and go up there, make a new script. So now we have this kind of classic 4-pane RStudio view. And before we move on anyway, I think I just want to go ahead and let's just save our script already. And you can just save the script directly into the project folder. You can also, if you're working on a project where you have multiple scripts, you probably want to make a scripts folder, but for now, for the sake of simplicity, let's just go ahead and make a script there. So here, we call it the map time workshop code. And so you can either put your script extension as .r here, or you can just leave it without an extension and R will automatically kind of put that there. So that's your basic R script format. All right, and our script should have appeared in our map time workshop folder. Great. All right. All right. Can pause here. Anything coming up in the chat that we should talk about, or should I just jump right into it?
I don't think there are any questions. Wes, do you have anything that you think Leah should talk about? Seems like we're pretty good.
Yeah, no, I am just trying to answer questions as they come up. Nothing that needs Leah's attention right now.
Okay, great, thanks.
All right. All right, so let's kind of go ahead and get started. So kind of along with the RStudio, if you haven't installed packages already, you can do that now. It may, if you run into trouble, this is going to be kind of one of the places where it gets kind of hard to troubleshoot virtually. But so if you've already installed your packages, great. You can kind of go over here to the packages. So same pane as the files folder, but there's a packages tab in the middle. There's a list of all the packages you've installed in case you missed one of them. So there's a couple of different ways to install packages. So in that packages pane, you can either, there's a blue box that says install right underneath kind of that packages files list. So you can either install it with the GUI, you want to install from the CRAN repository, type in the package name. So something like map view, it's going to come in here, you hit install. You can also install packages in the code line. So install dot packages is kind of the inline way to do it. So install packages, and then you will put your package name in quotes. So map view is one of the packages we'll be using. Just type in install.packages, run the code, either hit the run button. If your cursor's in the code, you can hit Control Enter, or you can just copy and paste your code into the and down here into the console. So everything. So your script is where you're kind of writing through everything and where you're holding on to things to save later. Your console is kind of where everything actually does all the running. So this is just, so I'm just doing a little bit of the kind of the upfront R basics right now. I'm probably gonna do a little bit less of that as we go on. But install packages, map view, install. And my computer's being slow today, that's fun. Okay. All right, so. All right, well, this is it. Okay, so this will probably because I'm running Zoom right now. But anyway, so even if you installed all your packages, so if you're familiar with R, you already know this again, but once you install packages, every time you run a new script, you have to load your packages as well. So the way we load packages in R, so load packages is with the function library. So we're going to load our packages here. So library, so if you type in library up in your
Hey, Leah, can I stop you for a second? Your audio's cutting in and out. Could you try turning off your video and see if that helps with your bandwidth?
Yeah, I also noticed my internet is slowing way down, even just trying to get, and I probably shouldn't have demoed that installation quite like that. Okay.
I think
right. Is that better?
Yeah, that sounds better.
Okay.
But also, just if it starts happening again, just talk slowly, and then we'll be able to not miss bits. But yeah, you're doing a great job.
All right, I'll leave the video off, and also I won't try to download anything else while I'm talking. That probably didn't need to do that either. So, all right. So hopefully that should fix that. And again, yeah, definitely break it again and let me know. So, all right. So not sure how much of that kind of cut out, but so once you've installed all your packages, you want to make sure you have to load your packages every time you are running a new script. So use the library code. So we're going to actually start, and the order in which you load your packages does matter. So we're actually going to start with the tidyverse package. So again, if you're familiar with running, or if you're familiar with working in R, you may or may not know what the tidyverse package is, probably do. It's another system of packages that's really, really useful for kind of handling data and data analysis. So cleaning up your data, pre-processing, analyzing your data, and it also kind of works a lot with, and so basically it's a large set of packages. It's always growing. Folks are developing new packages that kind of plug in. It's this shared, they call it a grammar or like shared syntax, where a lot of the packages are built in similar ways. And also as you're using the functions in each of the packages, they kind of share a similar way to plug in all the information. So it's a lot easier to remember kind of the sim. So we're gonna go ahead and run that. So again, so make sure it's running in the console. So the tidyverse is a system of packages. The package called tidyverse loads 10 of the kind of core packages in the tidyverse. So if it worked, a little pop-up should happen in your console. So attaching these packages names a whole bunch of packages. There's a conflicts pane that pops up. Don't worry about it. It's nothing broke. It's just telling you that, hey, this dplyr function filter when you use the function filter, it's going to use the dplyr version, not the stats filter that came with your code. So I'm going to go ahead and load that. And then we're also going to load SF, which is the simple features package. This is going to be the spatial workhorse for all of our vector data that we're going to use. So we're going to run that. So it's also part of the tidyverse. It just doesn't load with the tidyverse package. And so we should get our information there. Yep, and then the last package that we're going to download, or load, sorry, not download, today, or for now, is MapView. So go ahead and run that. All right. And I'm gonna start pulling more of this over to the iPad. Okay. All right. So first thing we want to do is import some vector data. So, and the first question to ask with that is, so where is R actually looking for, sorry, can't type and talk at the same time. So upload vector data, great. So first question is, where is R actually looking for our data? And a very, very handy piece of code to know is get working directory. So the working directory is where R is going to start looking for everything. So you just type in get WD and then open and close parentheses, just like that, and just run that as is. You're going to get your file path. So a couple of different ways when you're loading in vector data. So you, so again, we want to, we go back to our file pane over here on the right. So we have our project workspace. So if you recognize this file path that's showing up on your own computer, this should look familiar. It's your project directory. So it's that folder where the project is living. So a couple ways you can do this. You can either just go straight into your console and copy and paste your file path up here onto your script. And then because all of our data is living in the data folder, we actually want to make sure it's going to go all the way in. So you can just have your here. And what we're going to do is we're going to assign this to an object. So if you go over to all the way onto the left, I like to call file paths FP. It's a little bit easier to type repeatedly, and then use your assignment. So less than sign dash. So that whole file path. So that's your, so you can have file path like that. The other great thing about if you have everything in your project folder, you actually don't need to go through that whole thing and type everything all over again. You can use relative file paths. So because R is using the baseline default is your project folder, you can even just assign this as FP and then just call it data in quotes like that. And that will point it to the data folder inside your project directory. So go ahead and run one or both of those. It doesn't matter. Yep, so file path. And then, so to upload, okay. So to upload the data itself, we're going to use our first SF function of the day. So the data that we're going to be working with today is some watershed and stream data out of the Tahoe Basin. So once we start actually visualizing what we're doing, some of this might look familiar to all you California folks. So we're going to call this first. So basically what we're going to do is we're going to take our shapefile, we're going to load it into R and R Studio as a SF object, so simple features object. So we're going to call it watersheds. That's what we're going to call our object. And we're going to use the function stRead. So st_read. And we're going to set up through this data source name, so DSN. If I can, yep. So if you've ever wondered if people who've coded a lot know how to type without errors, don't worry, we don't. So DSN equals our file path. And then we're going to, so the first thing we want to pull in is our Huck12 watersheds out of the Tahoe Basin. So it's this, if you're in your file viewer over here, it's very handy. You're gonna say like, so it's the Tahoe_H12. And because we're pulling in a shapefile from a folder and it's an Esri shapefile, R is pretty smart most of the time and can figure out what type of file you're trying to pull in. So for shapefiles, we don't actually put the extension. We're just going to type in Tahoe H12 and this whole thing, so, but it's a name, so we want it to be in quotes here. So that should be, so in order to pulling this in, we want to have our, yeah, so it should look something like that. Just going to update the live code here for a second. All right, so watersheds is going to be our spatial features object, stRead. So our data source name should point to our file path, whichever one we had here, and then the name of our shapefile. So we're going to go ahead and run that and see what we get here. Great, so no, it worked if you didn't get lots of red text in your console. And so watersheds is going to show up in your data up in the upper right-hand corner in your environment pane over here. You're also going to see a whole bunch of information on what just happened over here. So reading layer, Tahoe H12 from data source, wherever you pulled it from. So it recognized that it's an Esri shapefile. Great, that's awesome. So simple features collection, and it's a polygon. So we just uploaded a set of polygons here. It also gives you some more information like what the extent is, so your bounding box, and CRS, which is basically code for your projection. So gonna actually, we can get a little bit more information, a lot of the same information. If we just type in watersheds, I'm gonna put this up here too. We just run, I'm gonna copy and I just copied and pasted that up here. So just run watersheds. Oh, and we got a lot of more stuff. So again, back to our, so simple features collection, polygons, XY, coordinates, great. Extent, coordinate reference system. So for those of you familiar with California and UTMs and NAT83, that's what this is. So this is the ESPG code. And I'm not going to really get into projections now. Kind of, that's a whole workshop day in itself. But when you're projecting and reprojecting your shapefiles with SF, you only need to use the this code here, and I'll get into that a little bit more in a little bit. So again, with all that, and then the rest of this is our attribute table. So we have a lot of fields here. So we have our ID field. We have the area of each polygon in square kilometers, acres. It's got some names. So these are our watershed names over here. HUC12 code if you're familiar with National Hydrography data set. And then some, just keep more information. So type, get into that in a little bit. And then special notice over here is our geometry column. So this is a list column. Not going to get into that just yet, but basically this is our polygon shape. So this is just a giant string of coordinates that forms kind of the polygon, and this is kind of that simple features setup for that. Gonna just, yeah, gonna get into that more in a second. That's what I'm cutting off in. All right, so useful things to know when you're kind of exploring simple features here. So if we want to check our coordinate system or use it in code later without kind of looking it up in the context of all of this, we can access that CRS code directly by using st_CRS, and then just type in the name of our simple features object, so watersheds, and oh hey, our studio is prompting that. You can just hit enter and it'll autocomplete for that, which is great. So if you run stcrs, get some good information here. So we have our user input, so again, that ESPG code. And then if you're familiar with ARC especially, so this well-known text is just this whole breakdown of exactly what's going into this geometry. So it's the name of the projection, and then kind of the underlying the datum, all this other useful information here. So that's a way to get a lot of good information if you're not sure what if you're pulling in shapefiles from sources you're not familiar with. It's a good way to kind of get familiar with that, and then also useful for projecting back and forth later on. So yeah, and if you're ever wanting to look up kind of these different EPSG codes, just going to, so there's a website called spatialreference.org that I can post elsewhere later, and yeah. Actually, I'll go ahead and post that over in the live code. So that's really useful for kind of looking up these different projections and back and forth. I think, yeah. So back to our watersheds object. So I've been calling it a simple features object. What does that actually mean? Well, so we can look up what we have here. So class is one of my favorite functions for figuring out what's going on in our life. So it's a combination of an SF object, and it's also a data frame, which means you can access and manipulate it a lot like a data frame, which is really, really great. Another really useful function for figuring out what's going on is the structure. So str watersheds over here. If we run that, we get a whole lot of information here too. So here we have, so again, if you go up to the top, so it tells you classes, how many, so 10 or 11 observations of 10 variables. So we have 11 polygons in our shapefile here. We have 10 different fields in our attribute table. And so, and if you're familiar with R, you can do this with data frames too. And so each column in the data frame is listed here. And then we also have our kind of list column here. So you can see that all of these, so not only can you see kind of what the names of your fields are, you also get, so it also tells you what type they are. So numeric, factor, numeric, factor, and character are kind of the most common. You can also have a couple of other different types of classes. So, and then our geometry column is our list column, which is, it looks pretty intimidating and it can be difficult at first to kind of figure out how to access individual aspects of that. If you are ever trying to, actually, no, hang on, I'm gonna back away from that and get to that in a second. So again, different ways to look at your simple features object. So classes, structure, you know that. Go ahead and put that. So, and because it's essentially a data frame, you can access it a lot like a data frame, which is really great. So if we want to just get a list of what the names of the of our watersheds are, we can just say watershed and then use the $, just like you would access a column in a data frame. Run that. Oh, and I spelled watersheds wrong because there's more of them. There we go. Okay, so we just get our list of watersheds like this. We can look up the class of our individual watersheds. What kind of a class is it? Well, it's a factor. That's useful to know. Factors are stored a little bit differently than just character tests are, or character fields are. They've got underlying numbers, which we're not going to get into, but that can give you headaches if you are trying to deal with that and don't realize that that's what's going on. So we can see our look up just the areas of our watersheds, see what that's going on. So notice when we had our factor, we had the levels were listed up here, and here we just have numbers. And we can get into that as well. And then you can also access, if you're just looking to do some quick summary statistics, it's a lot easier to do this in R than it is in something like ArcGIS, because you can just start accessing these columns directly like you would in R and the regular data frame. So you can say, okay, well, what's the range and size of our watershed? So you just can use range, say watersheds, area, kilometers squared, and then run that, and oh hey, it spits out. So we've got quite a bit of a range in size here on that. So that's pretty cool. Yeah, and just to kind of really reinforce, so there's a couple of, so when you're accessing data frames in R, you probably know that there's a lot of different ways to do that. There's lots of different ways to do everything in R. Some of the things that are identical in accessing data frames in R for normal data frames don't behave quite the same with SF objects. So again, when we were kind of looking at just using the $ as a way to kind of do columns here, that just gives us the list here. But if we do the same, so if we do another way to access our column, so another way to do that is watersheds, use indexing, so use those square brackets, and then you have to put the field name in quotes. So we have name quotes here. So watersheds, brackets, make sure, and oh, and you need to put a comma before the name if you're not familiar with indexing in R. So run that, and that actually looks very different from our just using the $. So when you index in this way by name rather than by $, or by, if you index using just the column position, so you can say watersheds, sorry, typing. Getting used to a new desk it's been interesting. So you can say, okay, well, you can index by column position as well. So here you have our areas instead. So the geometry column comes along for the ride when you index by name. So this is depending on what you're trying to do, you want to use these different indexing, because sometimes you want the geometry to come along. Like if you're plotting something, which we'll get to in a second, sometimes you don't want it to come along. If you're just trying to do analyses, you just want to call this one column, then you're going to use that $sign, because otherwise the geometry column is going to be there whether you like it or not. So sticky geometries, so they call them sticky geometries because the geometry just sticks to the data frame or sticks to the column you're trying to index like this. Can be really useful. They can also be kind of a pain to figure out how to deal with sometimes.
Leah, is this a good point
Yes.
to interrupt you and ask a question?
Yes.
So a couple people are having some trouble with their CRS doesn't match yours. And I think maybe either you skipped the line about the reprojecting, or maybe people just missed it. So if you could go back and talk about that line on your script, that might be helpful. It looks like line 40 in the materials on the GitHub.
Oh, interesting. Okay. I wonder, so I haven't, okay. So I haven't reprojected anything yet. If you're, okay, but we can do that. So if your ESPG code doesn't match mine, we can get to this. Okay. Let's get something. Yeah. So let's go ahead and yeah. So we just. So a couple of different ways to reproject in. I wonder what. Sorry, I'm getting distracted by trying to figure out where that was going to be. So, all right. So a couple of different ways to project in using SF. So we can just go ahead and say watersheds. So the main function to do the reprojecting is going to be st_transform. So st transform, and then just type in watersheds, and then we're going to set the CRS using that EPSG code. So CRS equals, so in this case it's 26910. Yeah, so if you go ahead and run that, and then we can check our, so again, then to check it, make sure you use the stcrs watersheds. So that shouldn't have changed anything for me, but hopefully if the projection file was still in there, so even if you had a different projection, hopefully the projection file still came with your shapefile. So hopefully it will have transformed correctly. If that didn't work, then you may have lost your projection file component of your shapefile. So you might need to re-download that. You can also set your projection, but depending on the projection may have changed. If you downloaded your data a while ago, that might have changed. So that could break some things. But I think you can also assign. Let's see if it lets me do this. I don't actually remember if this is what you're supposed to do. Actually, well, did that seem to fix things for most people? Is that? Okay. All right. Cool, we got one yes vote. That's exciting. All right, let me make sure that's live code. Great. Okay, good. I'm glad that worked. All right. So going back to. Let's see. Okay. All right. Cool. Go ahead. Go there. So. Okay, so yeah, so I just want to really quick again get back to that geometry list column before we start actually getting some visuals here. So you can look at, I just want to take a closer look at so if we look at the class of the watersheds geometry file here. So just this column itself, it's got the polygon feature, and it's also so simple features class. Sorry, I forget exactly what that stands for. Simple features collection. There we go. So the column itself is what's holding all of that spatial data in there. So list column is, so it's set up so that polygons can have holes. And it's gonna, if you just look at kind of the column itself, so I'm just gonna copy and paste this here. So it's got polygon for every row of our table here. And that's because you can actually mix geometries in simple features columns. I wouldn't necessarily recommend it, but it's something you can do. I think there are probably some cases where that is a useful thing. And so we can access that directly if we want to, but really a great way to kind of, the function st coordinates, actually not gonna type this down here, I'm gonna type this back up in the script. So st coordinates, that's going to kind of run that. That'll give you a little bit more information. This is actually an easier way to access your easting and northing fields here. So if you have a point file and you want to put the, this is looking a little bit funky because it's polygons, but if this were a points file, you'd have your easting and northing columns, and then you could, if you, for example, sometimes it's useful to put your point fields directly in the attribute table, not as geometries, but it's something like in ArcGIS, you can add your XY coordinates to your attribute table directly. This is something that'll let you do that. So that's just a useful function I wanted to point out there. All right, so what are we actually dealing with here? We've been, if you're doing GIS, half the fun is the visual maps. So half the fun, maybe more than that. So let's get a visual here. I want to do, so go ahead and, so we can just use our base plot. If you're familiar with R, just plot our object here. And depending on how quickly. All right, so this should pop up by itself. Okay, it did. All right, there you go. So it's pretty cool. All right, so we finally have a map. Yay. Sorry it took so long to get us to the map stage. So plotting our watershed. So this actually, so base plot does a little bit funky things with SF, but it's kind of useful if you're just really trying to see what's going on. Plots out just a plot for every column in the attribute table, which can be useful. It's kind of cool to see, okay, we've got some different color schemes here, basically mean like some of these are numeric and continuous, some of them are discrete. If we just want to get our polygons without all the colors, we can use, so plot and then use st underscore, sorry, keep doing this down here, don't need to do that. So plot st underscore watersheds, or sorry, underscore geometry, watersheds. And this will plot just the vector geometry. And you can do the same thing in a slightly easier way if you just go plot watersheds and then $, and then your geometry column. And it'll go ahead and plot that. So, and then here's one of those places that the sticky geometries kind of comes in handy. So if you, instead of plotting your field with a $, you can choose, okay, I want to look at, okay, what kind of watersheds do I have here? So you can say watersheds and $, and then that HU type. So capital H, capital U, capital T, but lowercase the rest, HU type. I'm sorry, I did that wrong. So just your watersheds, use the indexing bracket and then do in quotes HU type. There we go. So if you just use that and then make sure you close all of your parentheses there, go ahead and run that. Then we have our, we can just access one field at a time, and then it has all these nice, just built-in, very basic, like just plots out the name of the field and then what kind of watershed we have. So water body, so there's the lake. All right, great. And then however, like frontal watersheds, they call them, so ones that drain directly to the lake. Is what that S kind of stands for there. S being standard. So that's pretty great. Also, one of the great tools in R is using map view. So we're finally getting to map view. So map view is great because it's it's a combination of a very quick and easy way to get an interactive map, but it's also highly customizable, which I'll get to later. So if we have time. So we run the map view of just watersheds, and hey, we have this map, this interactive map that you can kind of pull around. You get some IDs here, and if you click on any of these watersheds, you can actually get the whole row of attributes for that individual polygon, like that. So that's pretty great. And we can also, if we want to change the color, we can do that. So map view, watersheds, and then comma, and then z call is the equals, and then name your field again. So HU type. So and this will kind of display it more like we did with the base plot. So if you run that line, then you get, and then it's color coded by the field that we chose there. So that's pretty cool. Yeah, so map view is great. Hopefully we'll have time to get to that a little bit later. All right. So let's talk about spatial operations. So you can do a lot of your very basic spatial operations, vector operations, just like you can in your graphical GIS. So let's load in another layer to do this. And one of the nice ways to kind of, without using the files pane, if you want to kind of don't want to keep toggling with your tabs, you can go check on what files are actually in that folder. So list files, and remember we had our file path that was pointing to our data folder. So if you remember, we called it file path. So if you go, or FP rather, so list.files, and you could just put your FP. Just put that file path object directly into these parentheses and run that, and then you get this entire list of what was in that folder. So with shapefiles, it's always a mess to look at, but we want Tahoe streams. So what we're going to do is we're going to call this new object streams. So streams, assign it to the object st_read. So again, data source name DSN equals FP. It's going to point to that folder we just looked into, and then we want Tahoe _streams. So run that, and might take a second. So again, so we successfully read it from our data source. Great, simple features collection with almost 11,000 features. Don't try to map this right now, that's a lot. So geometry line strings, so these aren't polygons, these are lines. And we have all that kind of other information there as well. And again, you can just look at the attribute table by just running the name of your object streams, and we get all that nice kind of attribute, get the attribute table along with that spatial information. All right, cool. So all right, so we have a lot of streams. That's a lot to look at, and we want to actually be able to map this without having to wait forever for all those tiny little stream segments to load. So if we just want to look at, so if we go back to our, so if you still have your viewer up over here, you can go ahead and look at your, let's just look at the streams in two of the northern watersheds. So if we can go back over to our lovely interactive map over here. So we're gonna do a filter by attributes over here. So, all right. So, but the first thing we're gonna do is just isolate our watersheds just to those two northern watersheds. So, so we're gonna filter this. So, all right. So we just want these two northern ones over here. So if we can click on it, and so we have our ID field over here. So we want ID number 99 is our first one over here. So we're gonna make a new object. So one of the lovely things about R is that you don't have to make a whole bunch of intermediate shapefiles. You just make some intermediate spatial objects, and then you only ever export out into your broader file structure one shapefile at the end, or fewer shapefiles at the end, which is great. So we want the watersheds north. So let's just call this WS_north. And so we're going to we're going to filter by attribute. We're going to index this. All right. So we're going to go watersheds, and then so for those of you who aren't familiar with R, this is going to look really goofy. Just kind of copy and paste it, and I'll try to talk through it a little bit. So watersheds. So we basically just want the watersheds column where. So we're going to say where the ID field is equals, that's important, 99. So again, that was our ID over here. So this is this watershed right here. So we want to say we're only going to take the watersheds whose ID is 99. And then we're going to use the or sign, which if you're not familiar with that, I'm not really necessarily sure where it is on a Mac, but I think most standard keyboards, it's the same key as the backslash rather than the /. So not the one we use in URLs, backslash, but shift. And then, so we either want ID number 99 or we want ID number 100. So watershed, go back here, say, or watersheds, $ID equals 100. All right, and then because we're subsetting by attribute ID, we're saying we want the rows. So the row is, so each polygon is a row, right? So we're going to say, okay, it's either, so we want the rows, which is going to bring our geometries along where the ID is 99 or 100. So let's go ahead and run that and see what happens. Okay, nothing broke. That's good. And then if we check out this and say, what does this look like? Cool. So now we have a simple feature collection with 2 features and 9 fields. And for those of you who are already familiar with the tidyverse, you can use filter on this as well, and then you can nest it the way you would with piping. I'm not going to demonstrate that just for the folks who aren't very familiar with R, but you can use, you can just say filter. And if you're using the pipes, you don't need to type in watersheds here, but you can just do watersheds. So basically this function says, all right, what is the object? And then we want where the ID field equals 99. So same setup here, just fewer things to type in, or ID equals 100. So you can also do that as well. And that should give you the same thing. Yeah, great. It's always great when things work out the way you think they will. All right. Okay, so now the text says we have the right thing. What do we actually have here? So you just go ahead and, so go map view again, WS_north. What does this look like? Run that piece of code. And oh, hey, we're down to 2 watersheds. Excellent. All right, so now we can take these polygons and go ahead and we can filter by location. So that's the first thing we're gonna do is basically we're not gonna join attributes. We just wanna, we're not really worried about bringing any attributes over from watersheds right now to streams. We just want the streams that are in that area. So we can do do this filter by location. There we go. All right, so we're gonna go. So now we're gonna take, so we're gonna create another new object. This is gonna be streams_north. We're gonna assign it to streams. So the object streams, and now we're gonna index this spatially. So there's a lot of ways to do this. So one of the most straightforward in terms of just code typing is just say, I want to filter streams by watershed north, our other features layer here. And we want the rows corresponding to watershed north. So that's it. That's all you have to do, which is pretty cool. So we're going to go ahead and run that. Oh, what's that? Hey, our projections don't line up. So that's kind of one of the cool built-in features of SF is that it won't let you do things without proper projections, which is great. So if you're like me and don't remember things very like from time to time, so we're gonna say, what was that ESPG code again for watersheds north? Let's look that up. So STCRS ws_north should be the same as watersheds. I'm going to run that. There's all of our projection info again. Okay, great. We've got our user input is our ESPG code. So now we're going to go ahead and reproject our streams layer. So streams, we're just going to reassign. So you can just reassign the same variable, same thing. So st, fewer object names to remember. So st transform. If you're going to use, well, it's not too difficult to transform vectors back and forth, but sometimes it's useful to call it a new thing. Sometimes it's not. So you don't have to if you don't want to. Transform streams, comma. So, and then we're going to type in our ESPG code here. So or just copy and paste it. So just copy it straight out of the console, paste it. So st transform streams, object streams with our new SPG code, run it. Great. Okay, so that worked. Now we're going to go ahead and you can just copy and paste this thing again, or just rerun the same code. You don't have to copy and paste it in the console again. Just assign so streams north, run it. Okay, nothing broke. Great. And now it's a little bit safer to look at it. So we should have fewer. So map view, streams north. So yeah, see what that looks like. All right, so we have some streams. There's some kind of wonky stuff going on here. So this is actually in the lake, and it's an artificial path that exists for reasons I won't get into right now. So if we're just trying to do things with these streams, we don't actually want weird streamlines in the lake. So we're gonna go ahead and we're gonna actually clip this. So this is essentially, so what we just did, the filter by location, is kind of in my head, the equivalent of the select by location tool in ArcGIS, where you're not actually doing any joining, you're just selecting and then exporting a new feature layer. This is actually going to be a clip. So if we're going to, so clip by polygon, just gonna go ahead and do that. And then so we want to, let's just call it something like streams clean. That's the cleaned up version. So, and then our function here is st intersection. So st intersection, and actually I guess I should point this out. So our studio is guessing what we want based on the different packages that are installed, and so you get different kind of lists, but we want intersection, not intersects in this case. So then we're gonna take our streams north, smaller feature to work with, and then so we're gonna clip streams north by our watersheds north, and then we could also do this with streams as well, but we're just gonna do this way for now. All right, cool. So here we're getting a warning message. This is just so it worked. It's just SF warning us that it's assuming that everything is spatially consistent. It's just giving you a warning message there. And if we look at this now, so our map view, you can also just copy and paste. So copy. If you don't feel like typing streams clean over and over again, you can just paste it inside your thing here too. That works. All right, go ahead and run it. And map view is going to think for a little bit, and then great, we have our streams, and there's no weird lines in the middle of the lake. That's exciting. Cool. All right, I'm going to go ahead and pause here for a second. How are we doing? I'm going to get into a little bit of rasters next, but I want to see if anything I should talk about.
No, I think we're pretty good. We're just clarifying some questions in the chat that I think are being answered there just fine. Wes, do you have anything you think Leah should talk about? Any questions for the whole group?
There are a few people who are having a problem where the CRS for the streams and the watersheds don't match. I think it's the streams and the watersheds. I don't know if you want to show how you would match those.
Okay, yeah, so if those aren't matching, so you can run that st transform on everything. So you could just, so basically reproject. So the two objects that you're trying to either clip or intersect, just run that streams code st_transform. So if it's the streams clean or the streams north, just have that be the object you're assigning it to and the object that's over here, and just transform that. Use the same ESPG code for both. And assuming the projection data is intact, that should work on that. So kind of the same issues as before there. So yeah, so before I reprojected the streams layer, that was breaking for me too, because we had reprojected the streams, this watershed's north of above, but not the streams layer. Okay. Okay, so, all right. So while folks are kind of figuring that out. So one of the major things that we think about kind of in hydrology or ecology when you're dealing with lakes and rivers and is what are the terrestrial inputs into aquatic systems? So what I mean by inputs, so what's coming into lake from the land, like nutrients and sediments are basically the two big ones. So the amount of nutrients and sediments coming into water bodies, whether it's streams or lakes or the ocean, is going to be influenced by a lot of things, but one of the big things we talk about is land cover type. So agriculture and development, lawns, cities, and agriculture in general tend to increase the amount of nutrients and sediments that are coming into these systems. So even in a lake as big and as deep as Tahoe, we still kind of see some of these impacts of all these nutrients coming in on kind of lake clarity, and also you see a lot more kind of algae growth in certain places. So one of the major ways that we kind of do analyses with these kinds of questions is looking at kind of, okay, so we have so in the US, I think pretty much everyone's in the US. So the National Land Cover Data Set is a national data set. It's updated every few years. It's fantastic, amazing amount of information. And so that's often what gets used. There's some other more area specific ones. But we can look at what the land cover, so forest, developed areas, wetlands, is surrounding the lake in this case. So I already included, so in our data folder over here, there's a TIFF file. So I clipped the National Land Cover Database to, or I didn't do this, this is a layer ahead, but so it's clipped it to the area. Actually, I did this. And then basically just, so wanted to kind of hone in on development, because the development class in the land cover database is not just kind of buildings and impervious surfaces, it's also lawns. And so basically, if you think about the Tahoe Basin, there's not a whole lot of development in general there. So most of the impact that we're going to be concerned about is going to fall under that development class. So this is just a binary raster. So it's just, is it developed or not? And I kind of lumped all of the development classes together if you're familiar with National Land Cover Data Set. So in order to work with rasters, we're going to actually pull in we're going to load another package here. So library, I'm going to use the raster package here. It's not in SF, which we're going to see in a second. So, or it doesn't deal with SF. So library raster. Personally, I find it the most intuitive for coming from graphical GISs. It's not the newest package that's coming out, and actually it's going to get, I think there's plans to replace it in both kind of the SP world and the SF world. But for now, I think it's a really useful kind of intro to dealing with rasters, and especially while the kind of fallout from SF getting entirely overhauled is kind of, all the packages that depend on SF are having to kind of catch up. So we're going to just talk about raster today. So if we load the raster package, a couple of things pop up in red down here that we want to pay attention to. So it's loading the required package SP. So that's how we know it's relying on SP and not SF. It's great that it does it for us. Awesome. So, and again, these following object is masked from dplyr. So now instead of dplyr taking over a function, raster uses both this. Raster has select and extract functions that are going to be, those functions are going to be used instead of the ones in this package that's listed here. So, all right, so there's a slightly different read-in process for the raster package. So, so if we just look at what our file path was again, right, it was in the data. So in the case of raster, we want to put the whole file path in, including the file name. So you can either do this copy and paste thing where you copy your file path. So you can say like field path to raster. You can either do this and then go over here and say, what is our file path over here? And just do slash, so nlcd underscore developed dot tiff. So you can either call it that. Actually, I won't get into the other way. Well, okay, so if you're familiar with R, you're probably familiar with paste 0. This is a kind of a handy way to not have to deal with doing all that copying and pasting yourself. You can just say, I want, so instead of manually copying and pasting it, you can tell R to do it for you. You can use paste 0. And then you can just use your, so do what you just did manually. So take your file path, and then in quotes, you're going to add just the name of the developed .tiff. So / because it's still file path. So run your file path, whichever method you choose. Then do that. Let's go ahead and do that. All right. And now we're going to actually load the raster in. So that's our file path to raster. So we're going to call this nlcd underscore dev. And then all you do is you type in raster and then parentheses FPR. So this is going to load our raster to an object. So run that. All right, and then if we want to look at this, we're going to say, all right, what have we got? nlcd dev. So same package map view. We can just use that again and look at our raster here. All right. So something a little bit interesting happened here. On the one hand, map view is really great because it basically said, hey, your raster's huge. That's going to take forever to load. We resampled it for you. Don't worry about it. So it'll still load in a semi-reasonable amount of time. Unfortunately, it also took this binary raster and for viewing purposes only. So this is still binary raster in our files here, but for viewing purposes only, it did a little bit of a gradient. So in these areas that don't have big developed patches, it looks like it's got values that are somewhere between 0 and 1. There shouldn't be any values between 0 and 1. There aren't in our raster, but just for viewing purposes, which is nice if you just want to see like, hey, did this work? What's the distribution? So we can, it's pretty cool. We can see, oh, hey, most of the development in Tahoe is South Lake Tahoe, North Lake Tahoe, which if you're more familiar with the area than I am, you probably already knew that. I think Truckee is in this area, so there's a lot more developed down here. Yeah, so, and there are ways to check that, oh yes, and if we actually want to make sure that, oh hey, is our raster actually still a binary raster, we can just say, all right, what are the unique, so just the way to look at the values of the raster itself in raster is values, so unique values nlcd underscore dev, so there's our object there, we can just check that. Okay, we just have no data, so the areas around the raster, and then 0 and 1. Good. So it didn't actually change our data, it's just changing it for viewing purposes for the sake of not waiting forever for our raster to load, which is always nice for the sake of our workload times. All right, so if we want to say, all right, what is the development in each of these, like how much development is there in each of the watersheds around Lake Tahoe, we're going to go ahead and extract our raster to feature. So what are the ones that are the most, what areas are the most developed? What are the areas that we're most concerned about for nutrient and sediment loading into the lake for certain kinds of nutrients? So we're going to extract raster to feature here. All right, so this time we're going to be proactive and actually check our projections ahead of time. So we're going to go back to using our full watersheds data set here. So watersheds, so all those polygons. All right, so what's our projection here? So watersheds, so we're still in that 83 UTMs, great. And then let's go ahead and look at our, oh, and also I should say, okay, yep, user inputs that ESPG code, cool. And then we also want to look at, so what's our, so for our raster here, what's going on here? So run that. All right, so a couple of things that are happening here, which I didn't realize that SF could do this, and I think this is pretty great. So we're still using the same SF function here, but SF is recognizing that this is not actually an SF object. It relies on SP. And instead of giving us the user input, I'm going to scroll up to what we got for watershed. So user input here, so the things you're using to reproject things, is this ESPG code. Down here, it's actually this. It's a whole string of things. So it's a totally different input. And SF is being nice and saying, hey, if you want to reproject this thing, this is the information you're going to need. Short, the upshot of this is that we don't actually have the same projection for these two, for the raster and for the vector. And those of you who've worked a lot with GIS know it's a lot easier to, well, it's both quicker to reproject vectors than rasters, and also it's a lot better to reproject your vectors, because if you reproject your raster, you need to resample, and that can change the underlying data and also takes forever, and so that's not great. So let's not do that. So if we're looking at this, we say, like, okay, this is, the projection is actually Albers conic equal area rather than our NAT83. And so if we don't want to type out that giant long projection string, which I don't, we don't have to, which is great. So we can say, all right, so we want to take, so our watersheds again, and we're going to turn our watersheds into Albers. Albers, I don't actually know how to pronounce that. Just read it. So we're going to transform our watersheds using ST transform again. So same function, which is great. You can just hit enter, autocomplete, watersheds. And then instead of manually typing in that string or typing in that ESPG code, we can just say, hey, what was the CRS of the raster again? NLCD dev. Oops, dev. Cool. Make sure you have the right number of parentheses there. All right, so we're just transforming our watersheds, and we're just telling R to get the CRS for us. We're not going to do it. Not going to do it. So just run it. All right, looks like it worked. And then we can check if that actually works. So here's our watershed Albers. So STCRS watershed WS underscore Albers. What it did. Is it Albers? There it is. All right, it worked. Great. And yeah, okay. So we did that. All right, so the other thing that we want to do, so SF and SP. So SF is good at recognizing when other objects are kind of SP, and also when it needs more complex. So Albers is actually a CRS that needs a little bit more information than just the ESPG code, it seems like. So, but the other thing is we need to turn it into an SP object rather than an SF object if we want it to be able to talk to raster using the raster functions. So, which we're going to use raster functions to do the extract. So we're going to make another new object. So WSSP, and this isn't it. So the function is just as, which is not necessarily the standard function, but it's the one that works the most consistently for me. So as WS Albers, actually, I think it might be the standard function now. Not sure. WS Albers, and then so taking our reprojected object here, and then we're going to turn it into a spatial object rather than a simple features object. So run that. Get this over here in the live code so we can copy and paste. All right, so that seems to have worked. All right, and now we're going to set up our extract function. So, all right, so again, another new object, which will just stay in the script and it won't have to be multiple TIFF files, which is, or, well, TIFF files. So I'm just going to call it watersheds developed SP. So WSDEV SP. And we're going to assign that object there, and then we're going to use the extract function. Great, familiar term, awesome. So extract. So we're going to extract. So from our raster, so NLCD underscore DEV, comma. You can leave this all in one line just for clarity. There's a lot more function terms here than I think would be used. So I'm just going to do this on multiple lines. So put a comma there, but don't put a terminal parentheses. So, all right, so NLCD dev is our raster, WS underscore SP is our spatial object. So that's our vector. And we're going to use so when we're extracting the polygons, we've got to summarize it in some way. So we're going to use the sum function. So fun equals sum. And if you're familiar with R in general and you are familiar with these kinds of functions, you know that if there's any NA values inside the polygon that we're extracting, if you don't tell it to ignore no data, it'll knock out all the values. So we're gonna say, remove the NAs for me. So na.rm equals true. Data frame, we want the data frame to come along with it. So we're gonna say, keep the data frame, please. Don't get rid of all of our attributes. And we wanna add this data to our existing SP file, so to our SP object. So keep the attribute table and also keep our geometries as it is. Just don't make a new thing, just do that. So we're gonna extract, so again, raster is the first term, then the vector, sum function, get rid of all the NAs, keep the data frame, keep it in our SP object, and then go ahead and run that whole thing. And that might take a second there. All right, yeah, so anytime we're dealing with rasters, it might take a bit. And given that we're all on Zoom, it's probably gonna take a little bit longer. All right, well, I guess, this is, I don't know if everyone else's is being as slow as mine. Any useful question or any questions that would be useful for me to answer that aren't?
Leah,
Yes.
one that came up was how would you add a new column to your data source? Something you derived from your data, maybe.
So in this particular case, this is going to add the value to our existing SP object directly. But I'm actually going to get to how to just add an extra attribute tables, or add an extra attribute field to the table.
Great.
Yeah.
Thank you.
Yeah. So again, with one of the reasons that working with SF is so great is because you can really just add, if you're familiar with R, you can just add fields the same way you would to a data frame. So that's pretty cool. But this, if everything works the way it should, then this because we said keep the data frame and just add it to our SP object here, it should just do that for us, which is exciting. And then, hey, okay, it's done. Done thinking. Excellent. All right, so what do we get? So let's just running the name of it. All right, so a little bit different from our SF object. So the setup's a little bit different. So class is telling us spatial polygons data frame. So we still have our polygons, 11 features, CRS extent, etc. And we have, yeah, so our variables, and then the names of our columns. So you can see with SP, it's a little bit harder to see exactly what's going on, but you can see the field, these are attribute names here, and then here's NLCD developed, which was the name of our raster, is actually now a column header, which is pretty cool. But because we want to be able to work with this the way we work with the objects, the SF objects before, we're gonna turn this back into an SF object. So still gonna call it WSDev again, but instead of SP, it's gonna be SF. And then we're gonna use the function, so st underscore, so the same prefix that we've been using for all these SF functions, and then as SF. So because it's already a spatial object, we can use this function, and then just do our WSDev SP. So turn our SP object back into an SF object, run that, and then let's look at this guy again. So I'm gonna just paste that, run that. All right, so now we're back to our more familiar format. Again, so all of our spatial information's up top, and then we have all of our fields, and down here we have an LCD developed name of the raster, and this is just this, because it's a binary raster, this is essentially the number of pixels, which is useful in some ways as a relative thing, but doesn't really mean a whole lot. And also this is kind of a lot to stare at. There's a lot of numbers and things. So let's simplify this data frame a little bit. So we're gonna take our, so I'm gonna call this, so we have our kind of our full SF object here. I'm gonna leave it as is in case I wanna come back to it later, but I'm just gonna make another new object. So WS, let's call it inputs. And we're gonna use the select function. Okay, so this is one of the reasons why working in RStudio with R is wonderful, is this is telling us, hey, you're about to use the raster select function, which I actually don't want to do. I actually want to use the dplyr select function. Dplyr is one of the tidyverse, one of the packages that loaded with our tidyverse package, meta package upload basically before. So there's a couple ways you can handle it. The simplest way right now for our purposes is just say, hey, I don't want to use the raster select. I want to use the dplyr select. Dplyr select. So that's basically saying use select from the dplyr package. And then we're going to select, so watershed dev sf. So this is our object. If you're familiar with tidyverse syntax, I'm not doing this quite the normal way, but I don't really want to get into piping right now. Just know that you can. So this is our object. And then we're going to have kind of a list of our, just the fields that we want. So I just want the ID field, area, kilometers, name. And then I'm going to actually do something a little bit different. So instead of just leaving that big long raster name in there, I'm going to say, so this is saying from my object before, give me these fields. And we're going to rename our raster field to dev underscore pixels, just to make it really clear what exactly that is. Developed. And then, so we're going to run that and then see what we got. So inputs, run that. All right, so now we have a lot less going on. That's helpful. And then really quick here. So, and because pixels doesn't necessarily mean a whole lot, let's turn this into like, okay, what's the actual area of our thing? So inputs. So we're going to make a new field. So this is how you add a field. So we're going to say, okay, this is our object, and then we're going to add a new field. So I'm just going to use that $. Say this. So the fields, we're going to call it, let's call it developed kilometers squared. So dev underscore km2. So this is going to create a new column without having to kind of specify that ahead of time. We're going to say, all right, the new values of this new column should be, so we're taking it from our inputs. So we want the development pixels. And then we're going to just multiply this by the, basically the area of each pixel. So the number of pixels times the area of the pixel, which is, so it's, I happen to know that the resolution of this is, so it's 30 meters squared. And then we also want to turn this into kilometers squared. So we're going to divide that by, so it's meters squared. We're going to turn it into kilometers squared. We're just going to, you can just, so you can also just do basic R, math with R, basic math with R. All right, and then, okay, what does that give us? So that gives us, so if we just, you can just copy and paste this down here. Hey, okay, so now we have something that looks a little bit more reasonable for kilometers squared there. And visually, we can look at this and say, watershed inputs. And so we're just gonna plot our field using that base plot again, run that. Cool, so we can see, okay, yeah, so our highest development watersheds are the ones right along the south edge of the lake here, South Lake Tahoe. So I think there's the highway goes through here and then also up here in the north. So that seems to match up pretty well with what we were seeing. So not entirely sure why necessarily, but plots show up in the plots, but you can actually toggle back to your viewer. That's where the map view ones are showing up. So hey, that looks pretty well. So that seems to have worked pretty well. And this is a little bit funky. Let's take the lake out of there. That's kind of weird. You don't really want the lake in there. So we can also, so just like you can just add a column. You can also just delete rows by index. Similar way to we've been indexing columns. WS underscore inputs. So I just know running out of time, so I'm not going to say I know off the top of my head. The lake was row number 5. If you run that and then look at, just copy paste our same, copy, paste, same code here, run that. Okay, now the lake is gone. Now we're actually getting what is going into Lake Tahoe, not just having the lake in there. All right, and really quickly, I just want to get the code for writing files out here. Unfortunately, we're not going to have time to really get into how to make how to do the map making in R, but I will post code on some of that and some more resources on that kind of after this. So everything's going to be up on the GitHub repository there. So really quick, writing out shapefiles. Just gonna. So always good to keep your raw data raw. We're going to go back to, so you can either do this in your File Explorer or Finder. You can also just do this over here. If I can remember how to do it. Okay, yeah. So we don't want to put things in our data folder. We want to make an output folder. So new folder, just make it output. Keep it there. Let's do that. All right, and so again, we're going to say our file path out is going to be that new folder we just made, output. And then the function we use to, so similar to how stRead was how we imported our vector, how we export our vector is going to be st_write. And our final object, so we don't need to, so this is the beauty of R, you don't need to export all of those files, have them cluttering up your file system. We just want to take watershed inputs, put it where we told file path output, and then we're going to name it. So same way we didn't put the file extension on, we're just going to say Tahoe inputs by Huck12 watershed. Not going to put the SHP. And then if you're redoing analyses and tweaking things, a couple of useful things to have in there, overwrite. You can tell it, yes, let me overwrite things I've already made or don't. If you do say overwrite, you just tell it, do you want me to append the data set? It's sort of like a, sometimes PDFs will ask you to do. No, we don't want you to append it. We just want to overwrite it. And then we also need to tell it. So SF is pretty good at guessing what shapefiles that exist are. Sometimes it gets confused, and we're just going to tell it, hey, this is going to, we want this to be, sorry, an Esri shapefile. And I'm not sure if I need to capitalize that or not. Let's see. Oh, I didn't actually run output. There we go. So object. So if you get object not found, that's probably because you didn't run it. All right. So that seems to have worked. So it's writing the layer. Thought about it. We go into our output folder. Hey, there it is. Great. Another quick thing. Often it's useful to have shapefiles, CSV files instead of shapefiles. I like to say, okay, let's just make a data frame, drop, geometry, inputs. Hold on. So yeah, so that'll then create, all right, so what do we just make here? Sorry, class, I'm just gonna paste this here. And now we just have a data frame and not an SF object. Which can be pretty great. And then you can just, you can export as a CSV, as a text file in the way you normally would on that. So you can, so if you're tidyverse, you can do write _CSV. So inputs, df, and then you can say, name it. So I'm gonna use that paste 0 code again. So to your file path, and then .csv, and then run that, and we have a CSV file now in our files. All right, we got 5 minutes left. I guess I should probably, unfortunately, didn't get to the mapping part, but I think I'm definitely going to post resources to the repository there. And if we go back here, so, and again, just want to plug, so I'll have all this, I'll put the live code up with a little bit of extra comments on the repository, so you can go back and find it if you either miss chunks of it or just want to go back and look at it, make sure that, or if something's breaking on your end and you don't know why, sometimes it's just a tiny little typo. And again, just want to plug the resources. There's a lot of resources if you're new to R. there's so many great resources out on the web. Just highlighted a few of them. Spatial R in general, so there's specific books, some tutorials, and especially if you're affiliated with UC Davis, definitely drop into DataLab drop-in hours. There's also, and for those of you who aren't familiar with the Data R users group community, it's a fantastic resource. Just asking folks affiliated with Davis, they've got a, this link here is a link to the discourse site, which is kind of they're replacing the listserv, and it's just a forum where you can ask questions about anything R related, and folks can kind of help you troubleshoot and figure out what's going on. Or if you're interested in what are cool resources for making nice graphs, they're great resources for that too. So, all right, any questions after that? I think that's all I got. Have time for anyway.
Excellent. Thank you so much, Leah. Wes, do you see any questions that I think we're just about out of time. So I think we probably won't have time for any more questions. I will say before everybody leaves, if you didn't have a chance to introduce yourself in the chat, please tell us who you are and where you're coming from so that we can record what our reach is. It's really important for us to have numbers to make these workshops happen. So if you think this is great and you want to see more of this, the best way to do that is tell us your name and where you're from so that we can make a case for continuing to do this. We really appreciate you guys attending and asking such great questions in the chat. And again, thank you so much, Leah, for doing this. I think it's always good to leave people wanting more, so you can go to the GitHub repository that Leah set up to get a little bit more materials there. And like she said, she'll be updating that as well. If anyone wants to stick around and chat for a few minutes, we'll be here. But otherwise, have a great day, and hopefully we'll see you in 2 weeks. We're supposed to have a workshop for Mapbox. So if you're interested in learning how to use the tools for Mapbox, that should be good as well. So I will turn on my video just so you can see somebody.
Have faces left.
So it's like we're still doing some troubleshooting in the chat window. I think what I will do is I'll stop the recording now, and that should be the end of this workshop. So thank you all.